very, very happy to be here. I think this is a wonderful meeting. My talk is something to do with great expectations or waiting for Godot. Um, I, I huge thanks to the organizers for organizing this fascinating meeting, and I hope that this series will continue in the future. I don't really have any conflicts of interest. My funding is from Canadian federal government. I'll make a starting assumption that rats can experience negative and positive affect. I'm just going to see if I can do something about removing the Zoom panel from my field of view. Okay, that's better. Okay, so I'll focus on 50 kilohertz calls in young adult rats today. And are these calls really a general readout of positive affect? If you read some papers in the literature, even today, that is the underlying assumption. But I think this is really needs to be qualified. It's true that a lot of things that would one imagine be rewarding to rats will increase the call rate, but I don't think call rate is a very useful measure for reasons that I'll give later. I'm going to focus on anticipation of rewards in this particular talk, and we're certainly not the first to have investigated this. We've got a long stream of papers starting back in the 70s saying that when rats are anticipating something rewarding, then they make more 50 kilohertz calls. And this could be anticipating sex, play, or sex again, but this time in Warsaw, electrical brain stimulation, social interaction, different drugs, in fact, food again, exercise, play. And if your own paper was not represented here, I'm sorry, but there's at least double this number, so I couldn't show them all. So I think it's well established that rats waiting for rewards tend to make more 50 kilohertz calls. Just a brief caveat, the early papers from around 2000 and before tended to use heterodyne recording, which, as most of you will probably know, is very crude and only detects calls that fall within a narrow frequency band. So you're going to be missing a lot of calls. I think that's a huge caveat, actually. Okay, so in terms of 50 kilohertz calls, they are heterogeneous. Are they all a general readout of positive affect? No, I think it's clearly not the case. And I'll credit Jeff Bergdorf, I think, for being the first to point this out. In fact, I think he and Jaak Panksepp were probably the first to propose that positive affect is signaled by a preferential increase in frequency modulated 50 kilohertz calls. And it was really reading papers by Jeff and also by Stefan Brzezinski and others that really intrigued me enough to take my first steps into this fascinating field. And our experimental subjects have always been young adult Long Evans rats. And my first student was Jennifer Wright, who had the task of recording tens of thousands of calls and printing out hundreds and hundreds of them in little squares and putting them on a big table and seeing if there was any pattern to them. And we recognized 14 subtypes of 50 kilohertz calls. This is a categorization scheme that greatly expanded what other people had been using up to that point. It's been adopted either in whole or in part by, I think, around 20 labs around the world. It's by no means not perfect. It is incomplete, as somebody mentioned yesterday. There are calls which could fit into more than one category, so the definitions are not entirely mutually exclusive. I'm sure there are different styles of scoring across different labs, but nevertheless, I think it's useful enough, and it does give us some interesting information which I don't think can be got through any other means yet. So through hard work, you can reach the stars. It is an incredibly backbreaking, laborious task manually scoring calls. We tend to use now macros where we take thin slices through each minute of a recording to try to reduce the workload. But nevertheless, it is a major limitation. And as somebody said yesterday, it's actually crazy to do this if a computer can do it better and faster. And I totally agree with that. Now, there are some other limitations of this method to point out. And one of them is that we're not sure that rats have got the memo. We don't actually know whether rats understand that there are 14 categories of 50 kilohertz calls. So what this all means to rats is really unclear at the moment. And I think this is a huge knowledge gap. Does a rat see these all as the same kind of call? What about trills? They tend to be very different in terms of variable, in terms of their duration and the number of cycles. So how do rats see the situation? We have very little idea at the moment, but I think it would be really important to figure this out. Okay, moving on. There's a problem, I think, with machine learning approaches, and well, I mean more than one problem, but we've tried ourselves to train VocalMat, which was originally designed, trained on mouse calls. We retrained it with, I think, maybe 20,000 rat calls that had been annotated in order to see whether it could accurately subtype our calls. And we found that very rapidly that it could definitely not handle 14 call subtypes, although it did a reasonable job if we only if we simplified it into 3 categories of calls. But that wasn't very useful to us. And I think this illustrates part of the problem. Supposing a rat makes flat and trill calls, and most of the time these are identified correctly. Supposing these rats also make a third kind of call, I'll call it the splat call, why not? Splat calls, okay, so occasionally they're misidentified as flats or trills, but no big deal, you would think. And most of the time these splat calls are correctly identified, so 8 out of 10 correctly identified. The problem arises though if flat and trill calls are occasionally misidentified as splat calls. Now you see that of calls that are identified as splat, actually only a minority are true positives. I'll be very curious to see how, as methods evolve, whether automated subtyping can ever solve this particular problem. And I very much invite discussion. I know there are people who know tons more about this than I do, and hopefully this kind of thing can be discussed later in the panel session. Okay, another thing to point out is that of these 14 call categories, 12 are frequency modulated. And so Jeff was saying that frequency modulated calls seem to signal positive affect. Well, the question for us has become which of these 12 frequency modulated calls. Also want to point out that in the literature now, some people are categorizing calls into, let's say, flat versus trill versus FM. But trills are a form of FM call. They are a subset of FM calls. So it makes no sense to have a third category called FM. It should be called something like non-flat, non-trill FM. Okay, so here's our call profile, and typically trills and flats predominate, and we express this as percentage prevalence. So if you added all these up, it would come to 100%. And notice that we have a category that I haven't mentioned, unclear and miscellaneous. And so how do we derive this? Well, sorry, I should also say that we strongly believe that percentage prevalence is more informative than absolute prevalence because absolute prevalence, so call rate per subtype, is strongly correlated with the overall call rate. So if you give a drug like amphetamine, that's going to increase the overall call rate. Everything's going to go up pretty much. If you give a sedative drug, everything's going to go down. Boats rising up and down on the tide. So we don't think that absolute call rates are the way to go when talking about call subtypes. And you can represent the call profile as a pie chart. There's at least 2 ways to make a pie chart. One would be to pool calls from all rats first, and only after that calculate the call prevalences. But this would not be a good idea because, as we all know, rats vary enormously in their call rate from one to another. And if you do it this way, then the high calling rats will have an undue representation. They'll be overweighted in the pie chart. Instead, this is just to emphasize how much rats vary in their spontaneous call rate. Not only vary, but this is a temporally stable trait, which is maintained even after a 3 months gap. And interestingly, it's not just call rate, but it's also the propensity to make flat or trill calls that is also very dependent on the individual rat and temporally stable. This is really just a shameless plug for Aditi's paper, which I rather like. Okay, so back to this. So the way we calculate the call profile and the way we calculate the pie chart is we take individual rat call profiles and then we crunch them into a mean so that each rat gets an equal say in the result. So this was, in fact, a pie chart from our first paper and showing that single tested rats were making mostly flat calls, whereas in parallel, pair tested rats made more trills and fewer flats. So although the percentage of trill and flat is a stable trait, it is also modifiable. And because rats like company and presumably experience more positive affect here than here, this started to make us think that trills and flats might give us an idea about positive affect. And here I'm summarizing most of a decade of work showing that amphetamine, cocaine, morphine, play behavior, these all increase the percentage of trill calls at the expense of flat calls. Nicotine, which is only mildly euphoric, if at all, in humans, didn't really change this trill-flat ratio. Anxiogenic drugs the same, whereas a couple of demonstrably aversive drug states produce the opposite change in the balance. So so far so good. It looks as if trills and maybe trills in relation to flats give us an idea about positive affect. This brings me to work by Hiromi Tsushira. This was done more than 10 years ago. I hesitated to publish it for a reason I'll explain. Hope that this will be experiment one in a paper that we're a manuscript we're writing up at present. So this is where I start talking about anticipation. So here we have a classic design. We've got 11 pairs of young adult male rats. They're tested every day for 8 days, and the test is done either after overnight separation in order to increase motivation to play, or no separation. And after 5 minutes of waiting, a barrier, they can see each other, smell each other, etc. Then they get to play over here. And this is done again for 8 test days. The overnight separation definitely increased how much they played here. So you could say it increased their motivation to play. And if we look at what kind of calls they're making when they're playing, well, it's trills. It's trills on the first day, it's trills on the last day. No big surprise there. Of more interest, though, for us is the anticipation phase here. What are they doing while they're waiting? Well, they make more calls as the moment of reunion approaches, particularly after overnight separation. So they're ramping up their call rate as the moment approaches when they're going to be able to play. And that's on the last test, not so much on the first test before they know what's going on. Okay, call rate, interesting up to a point. What about call subtypes? What kind of calls are they making while they're waiting? Well, on the first day, they don't know what's coming. They've never done this before, so flats and trills. But on the last day, trills predominate clearly over flat. This looks rather like the profile when they're actually playing. So this seems to make sense. Reward anticipation, pleasant experience, positive affect, increasing trill calls. However, you might have spotted that there's no difference between no separation overnight and separation overnight. The separation condition produced more play behavior, presumably more pleasant anticipation at this stage, but no change in the percent trills or flats. So we have to think a bit more clearly here. It could be that this shift, which we initially thought is attributable to anticipation, maybe it's not that at all. Maybe it's something else that simply happens with the passage of time. Maybe as the animals become more habituated to the test conditions, for example. So that's why I didn't publish this work many years ago. Take two, with the help of talented undergraduate at the time, Ruben Chen. And so what Ruben did was that she did the experiment again, but this time she included a second group, a control group. They wait and then they don't get to play. And by comparing calling here, we can infer the effect of anticipation. And so we predicted that anticipation would increase trills at the expense of flats because based on the idea of positive affect trills. And we also predicted that this effect would be blocked by a beta adrenergic antagonist, propranolol. As a point of fact, we didn't see much going on with propranolol, so we ended up merging the propranolol data with the control data, and so that we can focus on anticipation. So that's what I'm going to show you now. So we predicted an increase in trills when rats are anticipating being able to play. Here are the call profiles for the no play group and the play group. And it's a little complicated to look at, but most of these call subtypes are not changed, not different between the two groups, but some are. So let's look at our hypothesis that trills would be increased. Well, there's a hint. Flats, yeah, flats went down. Okay, so hypothesis partly upheld, I would say. But interestingly, we saw this. We saw a decrease in short calls and an increase in another call subtype called flat trills. And this was really vindication for us because, you know, after many years of doing this fine-grained analysis with lots of rats and lots of calls, I was beginning to doubt myself and think, well, is it really worth doing this when most of the time, almost all the time, the only changes we see are in terms of percent flat and percent trill? Well, clearly something else is going on here. And that was male-male social anticipation. What about female-female? This is work also done by Aditi, and it's being written up as we speak. And again, we see the same thing. Decrease in short, increase in flat trill, this time in females. But as we all know, females are complicated, more complicated than males. And in some respects, there looks as though there may be a sex difference in terms of anticipation of social interaction and or play. Okay, the last study I want to tell you about is also headed by Aditi with ably assisted by Bridget Sieck. And here we were intending to look at sexual anticipation, but a reviewer pointed out that we couldn't really call it sexual anticipation because, as you'll see, there could be a social component to this. So very good reviewer comment. Thank you for that. And so we're calling it sociosexual anticipation. And this was done in the context of a amphetamine withdrawal. Why amphetamine withdrawal? Because this is an animal model of depression. As it turned out, our amphetamine regimen didn't produce any effect or very little effect. So what we did again is we pooled the amphetamine and the control data in order to show you the effects of anticipation. So this paper actually became available online yesterday. I will give you 10 seconds just in case you want to take a shot of the QR code. And here's the experiment. We have sexually inexperienced male rats, pair-housed. We have a squad of sexually receptive females verified by vaginal cytology and also by their courting behavior. Daily test sessions. And as I mentioned, amphetamine withdrawal didn't do anything, so we ended up pooling across drug conditions. Now, it may not be surprising to you if you don't know the literature. The literature says that even virgin male rats show a strong interest in sex. So we think that the anticipation that I'm going to describe is at least in part sexual, but it may also be in part social. Here we have 16 male rats. They are paired up with a partner, different partner each time. And there's a 2-minute waiting period while the tunnel is blocked. Then the door is opened and the rat can charge into this here where he can't actually do much. He can smell, he can touch through holes in the barrier, whiskers, noses, but not much more than that. He's going to find the female on this side is ready to go. She's wiggling her ears. She's doing darting behavior, just as sexually receptive females do, rats I'm talking about. And so that's basically it. The interest is what kind of calls are they making while they're waiting. But wait, I've forgotten the control group here. The control group waits, and then the doors open and nothing on the other side. So it's really by comparing the pre-access period here between the two groups that we're going to infer anticipation. And note that these are two separate groups. Okay, so just first of all, in terms of their non-USV behavior, the partner group went through the door faster, not much faster actually, but faster, particularly on the final days of the experiment, taking just a few seconds to get into this side, and then they spent more time in the gold box than the no partner group. Not too surprising, I think. Okay, so then what kind of calls and how many calls? First of all, call rate during the pre-access period. The partner group made more calls than the no partner group, not at first, but by the final test day, they're making more calls for sure. And not surprising, that anticipation increases call rate. But critically, what kind of calls are they making? We might predict an increase in trills and a decrease in flats. But actually, we didn't find that. No change, no group difference in either terms of flat or trill calls. Okay, did anything change? Well, yes, two other call subtypes which are of low prevalence. So split calls, which are really very, very low prevalence usually, and also composite calls. And you can see that with time emerges a difference between the two groups. And the partner group, anticipating the sociosexual female, increased the percentage of splits and also increased the percentage of composite. So again, this fine-grained approach has paid off. And what are these calls? Well, this is how they were originally defined in the Wright et al. Paper. The composite definition is pretty vague, I think. So I think it's a bit of a catch-all category. And has anybody else reported changes in these two particular call subtypes? Well, yes, there are reports that they're increased in rats when they are stroked. There's also a report from Candace Burke and the group in Lethbridge that these calls are associated with certain kinds of behavior during play behavior. So there are a few reports in the literature already about split and composite calls. There's also a report actually from, I'm going to mispronounce, but Bialy, a group in Warsaw, that composite calls are increased during sexual anticipation. So this may not actually be totally novel, what I'm reporting here. So final thoughts then, Great Expectations or Waiting for Godot? I have to say that this title appealed to me at the time, but it's really ultimately rather meaningless, and I apologize for it. In terms of call profile, I think I've hopefully persuaded you that there's mileage to be made from expressing call profile as a percentage rather than in terms of absolute rates of calling. Importance of the control group, I mentioned that because in the literature you'll find several papers claiming that they're studying anticipation without any control group, but merely comparing day one with final day. So looking for a change across time, which of course could be subject to numerous confounds. Does the kind of calls made during anticipation depend on the goal object, the kind of reward? Does anticipating sex differ from anticipating play, differ from anticipating food, etc.? I think some of our data suggests that, but direct comparison would be needed to really test that properly. Something we haven't looked at all is anticipation of aversive offense. That's of course also of interest. There was a hint in what I showed you of sex differences. I find it very problematic determining sex differences, because it can be so open to confounds. Are you really looking at a sex difference or a difference between batches of rats, or other factors? Happy to talk about that if anybody asks. Lastly, a huge thank you to the people who did these studies. Most of what I showed you today was done by Aditi, and Rubing also contributed, and others I mentioned along the way. And others shown here by name are people who've contributed a lot to our USV work, some of it being written up, some of it published. And thank you to the team. And lastly, thank you to Canadian taxpayers down here for recognizing the importance of studying rat ultrasonic vocalizations. And thank you for your attention.